No other star's death is as eagerly anticipated as that of Betelgeuse. This massive red supergiant is destined to give us one of the most breathtaking spectacles in the night sky, an explosive finale so bright it could outshine the full moon and remain visible even in daylight. Not long ago, astronomers believed Betelgeuse's supernova might be just around the corner. And now, the famous shoulder star of Orion is making headlines once again. Some scientists suspect it spins much faster than it should, possibly because it once devoured another star. Others believe it may have a mysterious companion, nicknamed Betel-Buddy. So, what's really going on with Betelgeuse, and why is it keeping the astronomy world on edge? We often think of our own sun as the ultimate measure of cosmic greatness. After all, this life-giving giant spans nearly 1.4 million kilometers in diameter, enough to fit about 1.3 million Earths inside. But compared to the true titans of the universe, even our mighty sun begins to look small. In the constellation Orion, about 650 light-years away, Betelgeuse dwarfs our sun in almost every possible way. The red supergiant boasts a diameter nearly 800 times larger than our sun and radiates an incredible 10,000 times more brightly, at least, under normal circumstances. However, a few years ago, Betelgeuse shocked astronomers when its brightness dropped dramatically in just a matter of weeks. While periodic fluctuations are common for Orion's shoulder star, this sudden and intense dimming was far from typical. To put this into perspective, astronomers use a unit called magnitude to measure a celestial body's apparent brightness. The lower the number, the brighter the object appears. Normally, Betelgeuse shines at around 0.3 to 0.4 magnitude, making it the 6th or 7th brightest star in the night sky. But in December 2019, it faded to 1.289 magnitude, dropping all the way to 21st place. This extraordinary change led some scientists to speculate that Betelgeuse might be on the verge of going supernova, something that is inevitable for a red supergiant nearing the end of its stellar life. And when that moment arrives, Betelgeuse won't exit quietly. Instead, it will unleash a titanic explosion, increasing its brightness by a staggering factor of 16,000 and putting on one of the most spectacular shows the cosmos can offer. Astronomers predict that Betelgeuse could one day reach an apparent brightness of -9.5 to -10.5 magnitudes, making it shine as brilliantly as the full moon, visible even in broad daylight. But the big question remains, when will Betelgeuse actually explode? The honest answer is, we simply don't know. What we do know is that in 2019, it hadn't happened yet. The dramatic dimming seen back then wasn't a supernova precursor after all. It was caused by a colossal plasma eruption that generated a massive dust cloud, blocking nearly 2/3 of the star's light from our view on Earth. Still, in theory, Betelgeuse could go supernova as soon as today or tomorrow, if it's already entered its silicon-burning phase, a stage that lasts only a few weeks. However, most astrophysical models suggest it's more likely to explode sometime within the next 100,000 years, or at the latest, within a few 100,000 years. Has Betelgeuse perhaps swallowed another star? That's one of the mysteries astronomers are still trying to solve. Another puzzle lies in its rotation. Observations from the ALMA radio telescopes in Chile reveal that Betelgeuse spins at an astonishing speed for a star of its type, over 5 kilometers per second, about 50 times faster than expected for a red supergiant. This defies the norm, since stars tend to slow their rotation as they expand. According to Jing Ma of the Max Planck Institute for Astrophysics in Garching, Bavaria, Betelgeuse is the only known red supergiant believed to rotate this quickly. This unusual spin is thought to be linked to the star's striking bipolar surface structure, yet another cosmic riddle waiting to be solved. One side of Betelgeuse shows a blue shift, while the other reveals a red shift of several kilometers per second. But what could be driving this unusually high stellar rotation speed? Scientists have proposed several possibilities. The first, and perhaps most intriguing, suggests that Betelgeuse may have once devoured a companion star. Around 100,000 years ago, when it expanded into a supergiant, it could have engulfed a star roughly the size of our Sun. In this scenario, the absorbed star would have transferred its orbital angular momentum to Betelgeuse's outer layers, dramatically speeding up the giant's rotation. This theory isn't just speculation, it has been tested through computer simulations and supported by real observations. Images from the Herschel Space Telescope have revealed regions of ejected stellar material on one side of Betelgeuse. These shell-like structures were originally linked to its future supernova event, but they also align remarkably well with the distance expected if a stellar merger had occurred. The second explanation comes from Betelgeuse's own surface activity. Massive bubbles of hot plasma rise and fall across the star, and the rapid motion of these bubbles could create the same red and blue shift seen in its spectrum. If this is the case, Betelgeuse might not be spinning faster than expected at all. It could simply be tricking astronomers with a cosmic optical illusion. If a large convection bubble, or several of them, moves toward us while another moves away at the same time, even a completely non-rotating star can give the illusion of spinning at incredible speed. A recent reanalysis of ALMA data, combined with advanced astrophysical modeling, suggests this is actually the more likely explanation. According to the researchers, there's a 90% chance that the simulated star maps were misinterpreted as showing rapid rotation. The culprit? The relatively low resolution of ALMA's images, which may have distorted the true surface motion of the star. But even if Betelgeuse never engulfed another star, that doesn't mean it has always been alone. In fact, there are intriguing hints that this red supergiant might have an undiscovered stellar companion, sparking the hunt for Betel-Buddy. So, does Betelgeuse have a partner star? We know its brightness and surface pulsations follow a cycle of about 400 days. Yet, there's also a second, much longer fluctuation, occurring roughly every 2,170 days, just under 6 years. The cause of this long-term variation has remained one of astronomy's enduring mysteries. To shed light on this cosmic mystery, a research team from the Flatiron Institute in New York reanalyzed all the available observational data on Betelgeuse, and their efforts paid off. Their deep dive uncovered surprising anomalies, starting with the discovery that the star's 6-year light cycle doesn't match the subtle 400-day pulsations. In fact, the longer fluctuations seem to be out of sync with the rhythmic pulsations. Yet, despite careful analysis, the team found no signs of other potential causes, such as rotational patterns, magnetic field effects, or convection currents. This left them with one compelling explanation that fit all the evidence: Betelgeuse is likely accompanied by a smaller companion star. Since Betelgeuse is often affectionately called Betelgeuse in English, the team nicknamed the companion Betel-Buddy. But what supports this idea? Most importantly, the strange 6-year variations in brightness align perfectly with the companion's orbital path. When Betel-Buddy passes behind Betelgeuse from our viewpoint, the light dips to its lowest point. When it emerges beside the giant star, the combined light peaks at maximum brightness. This smaller star might also act as a dust sweeper, shaping the surrounding dust clouds and further influencing Betelgeuse's changing glow. So why hasn't Betel-Buddy been spotted before? Likely because it's relatively small, estimated at just 1.7 times the mass of our Sun, compared to Betelgeuse's nearly 20 solar masses. It also orbits quite close to the red supergiant, at only about 2.4 Betelgeuse radii. This proximity means it's completely outshone by its colossal partner, and Betelgeuse's own pulsations and brightness variations mask its presence in the light curve. Still, the search isn't hopeless. With powerful telescopes, astronomers may yet confirm Betel-Buddy's existence, and perhaps even learn exactly what kind of star accompanies the dying supergiant.